Number 9, 2x plus 6y equals 2. 2 times 2x plus y equals 20. How many solutions does the given system of equations have? Well, let's multiply this out or distribute that second equation. That's 4x plus 2y equals 20. Note the ratio of coefficients of x to y, 2 to 6 and 4 to 2 are not the same. So these lines are not parallel. Parallel lines will have the same ratios of x to y coefficients in standard form. Therefore, the lines must intersect at 1 and exactly 1 point. So B is the correct answer. Now, a lot of students like to see that in y equals mx plus b format. Okay, we can do that. The first equation is going to be take the minus 2x, so 6y equals minus 2x plus 2, divide through by 6, and we get y equals minus 2/6 x plus 2/6. And the other equation, if we solve the same, would be 2y equals minus 4x plus 20, divide through by 2, and y equals minus 4 halves over 20 halves. Minus 2/6 and minus 4 halves are very different slopes, which means, again, we have two lines that are going to intersect. Okay? In fact, they're both negative slopes. It's just one is going to be flat and one's going to be really steep. So that's probably a better graph right there. In either case, B is the correct answer in number 9. Number 10, absolute value 2x plus 6 plus 4 equals 8. What is the sum of the solutions to the given equation? So first things first, I want to isolate my absolute value. So I'm going to subtract 4 from both sides, and I'll get absolute value of 2x plus 6. That's an ugly plus. 2x plus 6 equals 4. Okay, well, it equals a positive number. That's good. The absolute value must be positive. And I've isolated my absolute value. Now I'm going to interpret it as a distance to get my two solutions and the sum. So I know if I divide it through by my coefficient of x, I can essentially say the plus 6 halves is 3. That means we're some distance away from minus 3, my center point. And that distance is going to be 4 over 2, or 2 in either direction. So that's going to go from minus 3 to minus 5 if I go down, and minus 3 to minus 1 if I go up. These will be my two solutions, and that's going to be a sum of minus 1 minus 5 equals minus 6. The correct answer is going to be A for number 10. So if you're looking at this saying, whoa, wait a second, I don't really know, I'm not comfortable with interpreting absolute values as distance. How would we solve it algebraically? Well, what we'd simply do is take a positive and a negative case. So my positive case is going to be, always start with our absolute value isolated, 2x plus 6 equals 4. Our negative case is going to be 2x plus 6 equals negative 4. And now we'll just solve algebraically for both cases. Subtract 6 from both sides, 2x equals minus 2, x equals minus 1. There's that solution. Subtract 6 from both sides over here, 2x equals minus 10, divide by 2, x equals minus 5. Getting a little messy, but that's our next solution. The sum of minus 1 and minus 5 is minus 6. Correct answer for 10 is A. 11. So it looks like we've got a linear inequality. The shaded region represents the solutions to which inequality? Well, everything here is in standard form, right? Ax plus by equals or is less than or greater than c. Right away, if the signs in standard form are the same, plus, 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 must be a negative slope. This is going upward to the right. It's a positive slope. Okay? So C and D are wrong. We're looking at A or B. So which is going to be correct? I'm going to have a y-intercept of 0, 3, and my solution is going to be less than that. Well, if I bring the 3 over from here, add 3 to both sides, I'm always going to end up with a plus 3 intercept. It's going to be 3x plus 3 is less than or equal to, add y to both sides, and I get y. Well, that's not it. That says y is greater than 3x plus 3. That would suggest solutions up here, which is wrong. This is going to be our answer, B. 3x plus 3 on both sides, if I add 3 to both sides again, is greater than or equal to, if I add my y to both sides, I get y's cancel here and plus y on the right side. Y is less than 3x plus 3. Well, that's the case. Y is below or less than our line 3x plus 3. This line is 3x plus 3. The correct answer for number 11 is B. Number 12. Okay, I've got a downward facing parabola, and if I scan my answer choices, I'm looking at a series of vertex form quadratic equations. Okay, and there's a volleyball being hit, x seconds. What's the height? That's modeled in y. What is the right relation? So what equation in vertex form models this graph? Well, again, we need to know our h comma k, which is the maximum point. hk, our vertex, is going to be 1/4, 0.25, comma 6. So my quadratic equation, in vertex form, is always a x minus h squared plus k. Well, in this case, that's going to be a times x minus 1/4 squared plus k is 6. That's going to be x minus 1/4 squared plus 6. It's going to be D. I don't know A from the graph. I need another point to determine that. There's no nice and perfect point here. Well, actually, maybe 3/4 too. I could possibly plug that in, solve for A, but there's no need because every A value is minus 16 in these equations. So I really don't need to worry about solving for A. It's going to be minus 16. So the correct answer for 12, the correct vertex form, is D. That models the graph. Okay, trapezoid A and trapezoid B. They're similar. Okay, that means they have the same interior angles and they have proportional sides. They tell us A is 8 times the length of every side of B. So if that were 1, that would be 8. If that were 2, that would be 16, and so on and so forth, right? The area of A is how many times as large as the area of B? Well, here's the simplest way to do it. Area factors, I'll call that AF, equals the scale factor, the linear or length factor squared. Areas are length squared. So my area factor is going to be my length factor, which is 8 to 1, squared, which is 64. The ratio of area of the big trapezoid A to the smaller one B is going to be 64 to 1. A is 64 times. Now, some students, again, might not really understand this relationship because it doesn't matter if you're looking at a trapezoid, a triangle, circles, squares, or similar blobs. I don't care. The area factor will always be the scale factor squared if they're similar. The area of a trapezoid is 1/2 base 1 plus base 2. The average of the bases, that is the horizontal bases in each case, times the height, which is always the vertical height, right? The perpendicular, sorry, that doesn't look like a right angle, but it is, the perpendicular height, okay? So if we make our base 1 and base 2 8 times, this figure will be 8 times, and our height will be 8 times. So therein, our half stays the same. We're going to get an 8 times 8, which will yield to our 64 times area result. So again, I'm not going to go too in depth, but we could calculate the area of one and the area of the other given the trapezoid formula. Not necessary. Doesn't matter what the shape is. The area factor always equals the scale factor squared. D is the answer for 13.